Welcome to TopSolid 7. In this video, we're going to explore the sketcher within the TopSolid 7 platform. In our sketcher, we have two main ways to work. We can work in what we call the solving mode, which is the basic level of the sketcher, and then we have an operations level as well. And I'm going to try to define both of them for you and show you examples of where to use one over the other. The solving level sketch allows you to create any sketch you need and have the software help you solve it. In other words, set geometric conditions, dimensional values, and what have you. However, if you're making significant changes to the sketch down the road, maybe the operation level of the sketch would be better, because there you can capture your pure design intent and have TopSolid help solve the rest of the sketch. Let's have a look. I'm going to begin by making just a basic widget in the solving sketch. So to do this, I'm going to start a sketch, and I'm going to go ahead and click Contour. Now, before I begin my contour, I'm going to show off a little bit more of our sketcher. I'm going to come up here and turn on Dynamic Symmetry. In this case, I'm going to be dynamically symmetric about the orthogonal y-axis of my sketch plane. Now here you can see I have two dots chasing my cursor. So I'm going to start here, and I'm going to come off to the right, come down, over, down, and closed. Now, right off the bat, you can see how efficient that was to create a symmetric sketch. I'm going to go ahead and turn that off because I'm done with symmetry. Real quick, if I drag on this, you can see my design intent is being captured beautifully. Fantastic. Let's go ahead and start adding constraint-based dimensions. For example, this command here. Up here, I'm going to say that this is 4 inches. In fact, for today's sample, I don't really care about the size so much as I do about the overall functionality of the sketch. Maybe here this is going to be 0.5, and maybe here this is going to be 1/4. Thanks to the symmetry that I defined, everything is up to date. Next, maybe what I want to do is add some fillets to this as well, and here I'm going to use interior-exterior radiuses. So for my inside fillets, I'm going to choose an 1/8 inch, and for my outside fillets, I'm going to choose a 1/16 of an inch. If we go ahead and select that, you can see my inside corners are an 1/8, my outside corners are a 1/16. Perfect. If I go and make a change, for example, let's make this 3/8, everything updates as we would anticipate. My sketch is solved. The purple turned blue, right? And now let's go ahead and extrude this. I'm just going to extrude this for a couple of inches, 3 1/4 inches, whatever. So there is my part. Perfect. Go ahead and save. Now I'm going to do a similar thing at the sketch operation level. Okay, so here I'm going to start this in a different part file, and I'm going to start another sketch. In this case, I'm going to start by just starting my sketch at the solving level. Okay, I'm even going to start adding dimensions. This is going to be 2 inches. That's going to be that 1/2 inch, right? This is going to be 3/8. Perfect. And maybe up here, this is going to be some distance from here to here. Great, we'll call that 2 inches. Perfect. Now, from here, what I'm going to do is I'm going to go to my sketch operations. In sketch operations, these are pretty cool. So what I'm going to do is I'm going to start by repeating this sketch. Okay, the pattern is going to be one of symmetry. It's going to be an axis symmetry about that axis. Validate, and I'm done. Perfect. Maybe next, I'm going to put fillets in. And again, I'm going to use that interior-exterior fillets. So I'm going to say interior is an 1/8 inch, exterior is a 1/16, and we'll go ahead and select our profile. And you can see the preview of everything in there. And again, I'm done. Now, to the naked eye, what I just did is more or less identical to what I did at the solving level. But it's about to get interesting. Again, I'm going to extrude that some distance. So let's go ahead and divide these up. I'm going to take this sketch, drag it down over to here. I'm going to take the solving sketch, leave it over here. So now I'm looking at both of my samples. Okay? Of course, my dimensions are a little bit different, but if we look at both of them, you can see the general design intent was the same. Now what I'm going to illustrate is a design change. For example, what I want to do is I want to put a little cutout in that original sketch here. Okay? So I'm going to go ahead and edit this sketch. We'll look straight at it. And now what I want to do is go ahead and put my cutout in. Now check it out. If I go here and just make a little rectangle, like so, notice it didn't automatically mirror. Okay, that's fine. Maybe I need to turn on symmetry. So let's go back and turn on symmetry about orthogonal Y. That's fine, and I can go ahead and make my rectangle like that. And of course, this time it did mirror. That's fine. But now, even if I leave this on, it doesn't matter. If I go to trim and I say keep selected part, and I want to keep, pardon me, on profile, this part, notice that doesn't mirror. So I got to click over here again. Now I want to be on segment and delete, and if I delete on this side, I got to go delete on this side as well. But you'll also notice that there's no fillets here. And my fillets, it was clear, was supposed to be interior, exterior. So let's go back to this command. Let's select here again. And of course, it's going to apply those fillets. But I had to go and tell TopSolid to do this. Now, any software out there that is a constraint-based sketch, like this is, you would have to do that. And again, not the end of the world, but there's definitely work to be had. Now I can come in here and add my dimensions to get this to be whatever dimensionally I need it to be constrained. Now at the end of the day, you can see the part is up to date. Now let's go look at the operation level to see what we need to do. So here, first of all, I'm going to make this 3 inches. So it's like the other one. Perfect. And now I'm going to edit this sketch. Now when I edit this sketch, something interesting happens. Okay? First of all, it goes right into the operation level. Now, to be super clear on this, I want to show something to you. If I go to my history tree, and I go to operations here, and I go into my sketch, here we see the building sketch. That means we're at the operation level, and here you can see the solving level of the sketch, then the symmetry that I did, the repetition that I did, and then the fillet that I did. Conversely, let's go back to our extruded sketch here at the solving level, and this is again this part now. And if we look, there's no extra information because everything is contained at the solving level. If we go back here, we have operations applied to a sketch. Now check this out. This is where it gets really cool. I'm going to go in here and I'm going to edit the solving level of this initial sketch, right? And all I'm going to do is build that rectangle. Again, it's going to be some distance, right? I'm going to go ahead and trim this up. So might as well do this as profile trimming. I'm going to go ahead and keep this side. And then segment trimming, I'm going to delete this side. All right, that's pretty cool, right? But now watch the magic. As soon as I validate out of this edit, notice the symmetry is up to date. Notice the interior-exterior fillet is up to date as well. The difference here being is this. Whenever you're working with sketch operations, these are operations applied to a sketch. So when the history rebuilds, it rebuilds everything in order. So in this case, for the sketch operation sample here, I updated my original solving sketch, then the software reran the symmetry, put both details on both sides, reran the repetition of course, and reran the filleting for the interior-exterior fillets. With sketch operations, you can really capture your design intent and ensure that updates are done quickly and efficiently while maintaining your original design intent. I hope you found this video interesting. If you have questions, please reach out to us.